Hey everyone. Today we're going to look at graphing the transformations of y equals cosine of x. Remember, cosine and sine are the same shape, but cosine is the sine graph shifted over to the left by pi over 2. So a lot of the same strategies apply. We're going to do a couple of examples, and then we're going to come up with a general strategy for graphing sine and cosine based on our efforts. So let's get a feel for what we should do. First, as with sine, it's best to write this as 5 cosine of pi times the quantity x minus 2 over pi. Why is that so important? Well, because now we can recognize what the book calls our phase shift, right? That negative 2 pi. Okay, so if we take a look here, we get a nice big set of axes going. So just a quick review. 5 is the amplitude. Pi relates to the period, even though it's not the actual period. Negative 2 over pi is the phase shift. And negative 3 is the upward shift. Okay? Maybe it would even be best if we wrote down all these properties. The graph has, maybe I'll just make bullet points, amplitude 5, period 2 pi over pi, which is 2. It's a little bit different, right? I'm not used to seeing that, but it's just a nice whole number, 2. I guess I'll write this as leftward shift, since that's the way I usually say it. Leftward shift negative 2 pi. Or you could say rightward shift 2 pi. And you could say upward shift negative 3. Okay? So again, I hope it's clear where we are getting those values from. Let's take 1 sec to highlight those guys, right? All right, now, let's see how we approach this. I'm going to focus on the x values first. Then I'm going to focus on the y values. So for the x values, we are shifted from 0, negative 2 pi to the left, which I guess means 2 over pi to the right. Sorry, negative 2 over pi to the left, which means 2 over pi to the right. 2 over pi, right, that's roughly 2 over 3, right? So we know that our period, if our period is 2, well, then I guess this point out here is going to be 2 over pi plus 2. That's roughly correct. Yeah, roughly. Maybe a little far out, but that's okay. And if you want the middle point, which you don't need, but if you want it, then it's that. Try to get some nice symmetry in your graph, okay? Anyway, now that we have our x's taken care of, we can look at our y's. Now, since we're shifting the graph down by 3, let's go ahead and note negative 3. Actually, you know what? If we're going to keep this to scale, negative 3 is actually about the same as, 2 pi plus 2. So, maybe about here, right? Negative 3. Actually, maybe this is just a little too far to the right. Maybe we'll shift this over just a little bit. That's a bit better, okay? Because this is negative 3. Okay. Now, again, we are getting that from our upward shift. Now, if that's our upward shift, then we're going to consider negative 3 plus 5, which is 2. We're also going to consider, way down here, negative 3 minus 5, which is negative 8. Does everyone see what we're doing right here? Our amplitude is 5, so we're adding and subtracting it from the upward shift. So now we have our y range, so to speak. Okay? So why does this matter? Well, because now when we want to graph cosine, remember the general graph of cosine looks like this, right? That's the basic gist of it. But since we're shifted, I guess we're starting here, we're ending here. And it's a pretty steep decline. We have something like that. I'll try to make that the tiniest bit more symmetric. I think it's actually worse. One more time. Right there. Okay? That's your graph. That's our graph, right? It hits its nadir right in the middle there. Right in the middle of the x's, right? In case you want to write this down. You don't have to, but you can. It hits negative 3 right in between 2 over pi and 2 over pi plus 1. And then again, right in between 2 over pi plus 1 and 2 over pi plus 2. Right? Okay. So that's how we graph this. So is that pi x minus 2 minus 3. Okay, that's our graph. All right, let's move on to the next one. So here, a little bit different, right? In that we've got a negative number for the period, right? Or for the number, for the coefficient inside affecting the period, right? Negative 2 cosine, and we're going to again write this as negative 5 over 3, but then it's going to be times x. I guess that'll be minus 3/5. The way I got that, right, is that, you know, negative 5 times negative 3, 3 times positive 5, right? That would give us 1, right? Dividing by a fraction means multiplying by the reciprocal, right? Okay, and then great, minus 1 on the outside. Now, this is a little different here, right, because of this negative sign, right? We haven't seen this negative sign before with cosine. Remember, with sine, because sine was odd, we could say, oh, okay, sine of negative x is the same as negative sine of x. Well, there's something similar happening with cosine, but it's actually even nicer. Let's stick a fact right over here. The function cosine is even. Remember, the same way that sine is odd, cosine is even. i.e., cosine, actually right over here, cosine of negative x equals cosine of x. Okay. So why is that important? Well, if we go back down here, this is the same as saying negative 2 cosine of positive 5/3 x minus 3/5 minus 1. Now, again, note that we did need to factor out the negative 5/3 from, you know, both the x and the minus 3/5, right? We had to do that in order to make that, right? If we had just changed it to 5/3 x plus 1, that wouldn't have quite been right, right? Because the negative sign would have been off. Okay? So we have to keep it like this. All right? So again, note that there's like no negative there, I guess. Went away. Okay? All right, so now we can go ahead and sketch our curve. All right, so amplitude, maybe we should go ahead and write the amplitude here. Maybe I'll make it in red so it pops a bit more. Amplitude, absolute value of -2 equals 2. Period is going to be 2 pi divided by 5/3, or -5/3, right? It's the absolute value. So either by 5/3 or the absolute value of -5/3, which is 2 pi times 3/5, which is 6 pi over 5. I'll say left shift -3/5. So again, we're going to the right. And then upshift, or upward shift, -1. Okay? So let's take a second. Maybe you can pause the video. Try to graph it yourself. All right, so now what I'm going to do, right, let's consider our x values, right? Leftward shift of -3/5 means rightward shift of 3/5. Okay? Our period is 6 pi over 5, so that's like 18/5 or so, which is like, a little bit more than 3. So maybe we'll go over here. This is, 3/5 plus 6 pi over 5. Do your best to keep it to scale, but if not, then it's not the end of the world. Just make it clear that that is a plus sign. There we go. All right then. Now that we handle the x values, let's handle the y values. So we know that we've got a downward shift of 1. We also know that we are further, going down another 2. Maybe here, right? -1, -2 equals -3. I guess right about here, so -1 plus 2 equals 1. I hope everyone sees how we got that. Now, keep in mind, we do have a negative. Okay? So we just want to keep that in mind when we're graphing, because we're going to flip it, right? Cosine normally would normally do this or something, but instead it's going to do the opposite, right? Because it's negative, it's going to do something like this. Okay? So we're going to start right here, because it's cosine, and we're going to end right here. Again, it's cosine. And I guess we're going to get as high as here in the middle. So let's try to connect that. Something like that, right? And there's our graph. Okay? Easy as pie. All right, last but not least, let's try to come up with a general strategy for graphing transformations of sine and transformations of cosine. Well, just following what we did, I would say step 1, write as y equals a sine of b times x plus c over b plus d. Or, I'm going to make cosine pop a little bit more. Or y equals a cosine of b times x plus c over b plus d, right? The same exact thing, right? Let me try to make this pop a little bit more. by making it red, okay? Okay, now I guess I'll say step 2. If b is less than 0, which is say if b is negative, then I'll break this into 2 parts. A, recall that sine of negative x equals negative sine of x. And if you're talking about cosine, then recall cosine of negative x equals cosine of x. Okay? So that's the second part. That's only if b is negative. Okay? Step 3, I would say you want to identify your phase shift and your period, which should be, right, pretty obvious, right? So note that the phase shift, because again that's what the book calls it, or left shift, is well, I guess if I'm talking about the left shift, it would be c over b. And the period is 2 pi over the absolute value of b. So noting those two things, mark both values on the x-axis. Okay? Then step 4, note that the amplitude is the absolute value of a, and the upward shift is d. So now here's the thing. You're going to mark 3 values here, I think is probably best. So we're going to mark, I would say, d minus a, d, and d plus a on the y-axis. Okay? And then the only other thing I'd say at this point is step 5, which is that if a is negative, then I guess, or maybe I'd say flip your graph over the x-axis. Maybe I would just say, yeah, I guess I'll just say, yeah, I'll say flip, or maybe that's even a little too complicated. I'll just say draw the graph upside down. i.e. vertically inverted. from normal. Okay. So just a quick example, again, very, very generally here, but if we have an axis here, right, I might mark down, you know, this is negative c over b. Actually, I guess I should say, just to be clear, if the leftward shift is c over b, then we're going to mark down negative c over b. And then here we're going to mark down, I guess it's the red part, right? Negative c over b plus 2 pi over the absolute value of b. Okay, whatever that period is, right? Now, suppose we get shifted up a little bit, right? Maybe this is d. And suppose we have a bit of an amplitude, right? So this would be d plus a. And I guess down here would be d minus a. Okay? Let me actually clarify this instruction right here. Mark values negative c over b and negative c over b plus 2 pi over the absolute value of b on the x-axis. Okay? Those are the two values that we want to be adding. Okay, so anyway, right here, right, if we were graphing sine, for example, then it would be, well, let's see, right? So with sine, normally, again, we start like that, right? It looks something like that. But we're shifted. And remember, with sine, we start in the middle. So we're going to start here. We're going to end here. We also know that right in between, we're going to be here. So if a is positive, I guess we'll assume here, right, a is greater than 0, then our graph looks something like this. Well, maybe it goes up a little bit before. Just a coincidence that, you know, the top happens to be close to the axis. It doesn't need to be. I guess I'll just draw it up there. I want to emphasize that, like, the top does not need to intersect the x-axis or anything like that. Right? So it looks something like that. Right? Actually, maybe, you know what I'm going to do? I'm going to make this purple. Because let me do this when, yeah, no, that's fine right here. You know what I'll do? I'm going to copy the whole thing. Let's consider the example when a is less than 0. Right? So here, let's consider the case where a is less than 0. So what's different? Well, I guess the only difference here is that this becomes d. If a is less than 0, or sorry, a is less than 0. Nope, I said less than 0. Then this becomes d minus a, believe it or not, right? And then this is d plus a, remember, because plus a means you're adding a negative, right? right? But remember, if the amplitude is less than 0, then what's happening? Well, this happens, right? Well, just goes to show you my graph isn't perfectly symmetric. Maybe I'll just eliminate this and draw it again, right? We're going down. Whoop. Going down. Whoop. Down. Up. And there. Well, maybe a little too far, right? If we're right over here. There you go, right? So that's the inverted, right? It's just inverted. Okay, now with cosine, maybe I'll draw this one in, I guess I'll draw cosine in orange. It will be here. We would end there. At the bottom, be there. So go. Right, there's your cosine. And again, if we were inverted, then we'd be something like this, right? Okay. So try to memorize this general approach, but more than that, try to understand it. Try to make it make sense. Okay. All right, thanks for working with me. That's all I've got.